So now let's get into this idea of antiderivatives and indefinite integrals. Okay, so when we were doing differentiation, the idea was we started with some f of x and we applied a thing called differentiation, and that brought us over here to f prime of x. So differentiation brought us from f of x to f prime of x. Now the question that we're going to want to talk about is, let's say we're over here at f prime of x. We have that, and we want to go back and get f of x. All right, that idea would be called antidifferentiation, and we're also going to call it integration in a little bit of a different format. So, what does it mean to be an antiderivative? So a function capital F of x, so that's what we're calling it right now. A function capital F of x is called an antiderivative of little f of x if and only if capital F prime of x is little f of x. So the derivative of the capital F function gives us this little f of x. All right, so let's work through an example and see what goes on in this. All right, find a function whose derivative is 3x squared minus 1. All right, we're going to see that mathematically we're going to have some notation here. Right. We're going to be able to ask this with symbols. Right. And this is the symbol here that we're going to use, this what looks like a big elongated S. And that's really kind of what it is. So just off to the side here, I'm going to show you how we can make that symbol. All right. So what this is saying is we want to find out what function, well, at least a function that has 3x squared minus 1 as its derivative. And that's where this integration sign is telling us to do that. And then just like we have a dx in differentiation, we have this dx on the other side that's telling us that we're doing this with respect to x. Okay. So what is the antiderivative? What is an antiderivative? So obviously 3x squared, x squared would have to come from x cubed, and that would give a 3 on the outside. So x cubed minus 1, well, that would come from minus x. So there's a guess of an antiderivative of 3x squared minus 1. So the question is that the only antiderivative of 3x squared minus 1? Well, no. There are lots of others. We could have had x cubed minus x plus 1, or x cubed minus x minus 4, or x cubed minus x plus the square root of 3. Indeed, because anytime we take the derivative of a constant, it's 0, that there could be any constant coming after that x, right? The first two pieces are fixed there. So we always have the x cubed minus x, but then we can have any constant. So the way we end up writing this is to show that any constant would work there. So we write it as x cubed minus x, and then we put plus capital C. And this denotes here a constant, an arbitrary constant. So we're seeing that, yes, the antiderivative of 3x squared minus 1 always involves x cubed minus x, but then it can have any constant afterwards. All right. So is there a certain time when we get a specific constant? Well, think about this. Add to this question. So what is the antiderivative of 3x squared minus 1 whose graph passes through the point 2, 4? Okay, so let's go back to the question we were asking. What is the antiderivative of 3x squared minus 1 with respect to x? Well, we've said that that's x cubed minus x plus some unknown c. So let's call this whole thing here capital F of x, because it's an antiderivative. If we take the derivative of it, we'll get this thing inside, which we could call the little f of x. All right. So that would be the answer to the original part. What is the antiderivative of 3x squared minus 1? Now, if we want this additional piece, what would they really be saying? We'd be saying that we want the graph of the capital F of x to have the point 2, 4. In other words, meaning x is 2 and y is 4. But that, in function talk, that means f, capital F of 2, should give us 4. Well, let's do that. So we know what the function's supposed to look like. It looks like this x cubed minus x plus c. So f of 2, we know, can be done two ways. By plugging in 2 cubed minus 2 plus c, or we could just take the value, 4. So if we work this out, we see that 8 minus 2 plus c is 4. 6 plus c is 4. So c is negative 2. So our answer is actually that x cubed minus x minus 2 is the specific function whose derivative gives this 3x squared minus 1, but also includes the 0.24. So by adding that second piece and saying it had to go through a certain point, we see that the specific constant here was minus 2. Okay, so let's get a definition here. So what does the indefinite integral mean? So that's what we're defining here. The collection of all antiderivatives of little f represents the indefinite integral of little f with respect to x, and it's denoted by the indefinite integral of f of x dx. Okay, so we've just seen that there are a lot of functions whose derivative gives our little f. And so all of them together, we're going to see that they have something in common, but all of them together makes what we call the indefinite integral, and that's represented by this notation that we've started to introduce. So let's look a little deeper at that notation there. So we have our integration sign. Now again, we're calling this an indefinite integral, and it's not clear why we're calling it indefinite. Later on, we're going to have something called a definite integral, in which we're going to have numbers on the top and the bottom of this integral. But that's coming later, and that's why it'll be a definite. But for now, we're just calling it an indefinite integral. And so we have the integral sign right there. We have the function, which we call the integrand. Then we have dx, which tells us that our x is our variable of integration. So that's the format. So we have basically this integral dx, and we put the function inside, and that's our indication to do the indefinite integral. In other words, find all the antiderivatives. So then out of that, we're going to get a part of the function that's always the same, like we saw the x cubed minus x before. And then we have this constant of integration, this plus c, that we have to remember to put so that we get all the possible antiderivatives. Okay, so this part here represents the core of the antiderivative, but it's only the thing that's common to all of them. And so what we get when we add the plus c is all of them. And in fact, what we refer to it is as a family of functions, because they all are the same as far as this capital F of x part is, and then they're all related by having different little plus c's afterwards.